All right, hello, we're on lesson 92. We're on page 443, so make sure your book is open, make sure you're following along. Please make sure that you are not fast forwarding through this video and getting to the very end to where you can just see all the answers on the board. That's not very cool because that's just not very cool, so don't do that. All right, go ahead and watch the video. I know sometimes, especially these last few videos have been a little longer. I understand, I get that. And if maybe you solved all the problems and you're just stuck on one problem that you need help on, then I guess maybe you can forward, but don't forward this. How about this? Don't forward the lesson. Let's go through the lesson together, and then if you want to forward through and get to the final answer on a couple of them, then that's totally okay. But don't forward through the lesson. Got it? All right. We're on page 443. As we've already learned, according to the book, from lesson 32, we began writing whole numbers in expanded notation. So here we have the number 365 written out in expanded notation. So the 3 is in the hundredths place, so we've written it as 3 times 100 plus 6 times 10, which the 6 is in the tens place, and 5 times 1, and the 5 is in the ones place. But we're going to learn a new way of writing them. We're going to start writing it in expanded notation using exponents, okay? So on to the next page, page 444. Here, the number 365 is written in expanded notation using exponents. So instead of writing 100, now we have 10 squared, or 10 with the exponent of 2. And that just means it's 10 times 10, which is 100. And we have a 6 times 10 with the exponent of 1, which is the tens place. And then we have 5 times 10 with an exponent of 0. And that is equal to 1. Okay, so whenever you see the 10 with an exponent of 0, that means it's 1. Okay, there in your books and here on the board, you can see the different exponents that we can put to the number of 10. Okay, so here we have the ones place, if I'm not mistaken. Yes, the ones place, the thousands place, the millions, the billions, and the trillions place. And this is where you can kind of see why we would write the numbers with exponents instead of all the zeros. So take the number 186,000, okay? So we see the speed of light is about 186,000 miles per second, which is crazy, that's really fast. And we've been asked to write 186,000 in expanded notation using exponents, okay? So our first one, the number 1, we see is in the hundred thousands place. So if we look here, ones, and this is the thousands place, this is the 10,000s place, the 100,000s place, and the thousands place. I'm sorry, the ones, tens, and hundreds place. Okay, so this here, this 10 with an exponent of 5 represents the hundredth thousandths place. In order to represent it in our usual expanded notation, we would have to write 1 times 100,000. Okay, so we're talking a lot of zeros there. If we go all the way to the trillions place, we'd be writing 14 zeros down. So you could see why this expanded notation uses the exponents to show expanded notation. Okay, so here we're going to do the same thing. We've got the 1 in the hundred thousands place, represented by 10 with an exponent of 5. Then we have the 8 in the 10,000s place, okay, represented with an exponent of 4, and then the 6 in the thousands place, represented with an exponent of 3. Okay, here we see the ones place, the tens place, the hundreds place, thousands place, 10,000 place, and 100,000, and this goes on. So here we have the 1 millionth place, 10 millionth place, 100 millionth place, and 1 billionth place, 10 billionth place, 100 billion, and all the way to the trillions. Okay. Now the zeros, just like in regular expanded notation, we don't represent. You don't have to write 0 times whatever the place value is. Just the non-zero digits. All right. On to the next one, order of operation with exponents. So in the order of operations, we simplify expressions with exponents or square roots before we multiply and divide. In the last, I think it was 3 lessons ago, we learned the order. First we multiply and divide from left to right. Then we do the numbers in addition and subtraction from left to right. Okay, here's our order of operations from here on out. We know that the first step is we need to simplify the numbers within parentheses first, okay? So number 1, simplify within parentheses. Next, after that, we simplify powers and roots. Remember, powers are those numbers that have exponents, and roots are your numbers with, right down here, this symbol, okay? So numbers within these symbols, so that is asking for the square root of 16. So powers and roots, those are the next numbers that you need to simplify. Then after that, number 3, we multiply and divide from left to right. And then finally, add and subtract from left to right, okay? And here's a way to help you remember. Some students remember the order of operations with this memory aid. So I have it down on the board, you have it there in front of your books, okay? Please excuse my dear Aunt Sally. And if you have an Aunt Sally, she is excused, all right? So please excuse my dear Aunt Sally. We're taking the first words, okay? The first letters of each of these words to remind us of which step to do first, okay? So please, so that P reminds you of parentheses, simplify the numbers within parentheses. And then the E reminds you of the exponents, okay? So you do your numbers with exponents and roots next. Then, my dear, the first letters M and D, remind you of multiplication and division. So you do that from left to right. That's important, you remember that order. And finally, addition and subtraction. Some of you may never use this. You guys are smart, you guys are brilliant. You guys can remember this right off the bat, but if you're stuck in a test and you need to remember which order to go on first, this might help. Please excuse my dear Aunt Sally. Remember the first letters of those words. Try to connect those to parentheses, exponents, multiplication, division, addition, and subtraction. And always remember, it's important that you go from left to right. All right. So let's go ahead and work out this problem here. It's been worked out for you in the book, but I'll go ahead and go through it with you. We've got 5 plus 3 squared times 2 minus 8 plus 2 divided by the square root of 16. Okay, so the first thing we need to simplify are the numbers within parentheses. So I have 8 plus 8, which gives me 16. So now my question is 5 plus 3 squared times 2 minus 16, okay, because we simplified the numbers within parentheses, divided by the square root of 16. Our next step is to simplify the squares and roots, okay? So I need to solve this and this, so that's my next step. So 3 squared is 9, because 3 times 3 is 9, okay? So now I have 5 plus 9 times 2 minus 16 divided by 4, okay? So I solve the square root of 16 is 4. And then I solved my multiplication and division problems, again, from left to right. So I've got 5 plus 9 times 2 minus 16 divided by 4. So I need to solve 9 times 2 and 16 divided by 4. So now I have 5 plus 18, which is 9 times 2 is 18, minus 16 divided by 4 is 4. And now I can do my addition and subtraction in that order. So 5 plus 18 minus 4 is 19. Let me check something real quick. All right, just making sure we are still recording. And last but not least, powers of fractions. We may use exponents with fractions and with decimals. So use parentheses to indicate the whole fraction and not just the numerator, okay? So we're here. Later on, we'll get to the point where maybe the numerator is getting an exponent, but in this case, we're just focusing on the entire fraction. So we're on this part of the board. We've got 1/2 cubed, or 1/2 to the power of 3, okay, or with an exponent of 3. This fraction within parentheses could be written as 1/2 times 1/2 times 1/2, which would equal 1/8, because it's 2 times 2 times 2, and 1 times 1 times 1. Remember, when multiplying fractions, we multiply the numerator and the denominator, okay? And this is true also for decimals. A decimal within parentheses with an exponent is multiplied by the number of the exponent. So 0.1 would be multiplied by 0.1. If this were 3, it would be 0.1 times 0.1 times 0.1. In this case, it's 2. 0.1 times 0.1 equals 0.01. And we'll talk about this in a minute. The reason why there's 2 decimals is because when we multiply these two together, it creates 2 decimal places. So lastly, let's go ahead and solve for this one. All of these are examples that are written in your book. All of these are examples that you can follow along. Let me stand here. All right, so we've got 2 with an 2/3, in parentheses with an exponent of 2. Simply means 2/3 times 2/3. Remember, we multiply the numerator and the denominator. 2 times 2 is 4. 3 times 3 is 9, okay? In this case, we can't reduce that fraction anymore, so we just leave it like that. That's the final answer. But if your answer needs to be reduced, you have to make sure that you reduce it. All right, here we go. Let's go through our odd number problems. Let's go ahead and solve this. Number 1, we are on page 446. As stated in example 1, the speed of light is about 186,000 miles per second. The moon is about 250,000 miles from the earth. About how long does it take light reflected from the moon to reach earth? Round your answer to the nearest second. So if you ever look up at the sky and you wonder, oh man, I wonder how long it took the sun's light to reflect from the moon to come to me. Well, now's your chance to solve that question. So we've got the moon that is 250,000 miles away. It's important to show our unit of measurement here. It's 250,000 miles, so we represent miles with M. And then our speed of light is 186,000 miles, okay, per second. Remember that division, or that line can be read per, so miles per second. Okay, so we've got our units of measurement. To help me out with my division, I'm going to go ahead and cross these out, and I'm just going to focus on my denominator of 186, which is my divisor, and my numerator of 250, which is my dividend. So I've gone ahead and divided it. I see that 186 goes into 250 only one time, and so I put my 1. So 1 times 186, I write it down, and then I subtract it. And I'm sorry, I was looking through the camera and I can tell that all of this is pretty mushed up, so I apologize. That was just me borrowing from the 1, I'm borrowing from the 2, making that a 1. And I made this a 15, crossed it out, made it a 14, and the final number 10. So 10 minus 6 is 4, 14 minus 8 is 6. So now I've got a denominator of a remainder of 64. So I write it down as a fraction, 64 over 86. Then I simplified it a little to 32 over 93. All right. Now this is a small fraction here. We're told in the book to round to the nearest. What is it? Round to the nearest second. Yes. Round to the nearest second. So that gives me 1. Okay. The nearest second that I could round to is 1. Now where did I get second from? Well, remember here, whenever we deal with units of measurements, okay, we have to focus on these. So these get canceled out and I'm left with seconds. Okay, so the final answer would be 1 second. So in case you're wondering how long it takes the sun's light to reflect from the moon to Earth, it's about 1 second. Pretty incredible. All right, next we have number 3. If the sum of 4 numbers is 144, then what is the average of the 4 numbers, okay? Remember, when looking for an average, in this case, we're looking for the average of 4 numbers. We take each of those numbers and we add them together to get the final number. And then we divide it by 4. So we're going to work backwards. So we take the final answer, 144, and we divide it by 4. I see that 4 goes into 14 3 times evenly. 3 times 4 is 12. 14 minus 12 is 2. I bring down the 1. Then I try to see how many times 4 goes into 24 evenly, 6 times. So 6 times 4 is 24. Subtract it, gives me a 0. So the average number is 36. Okay? Next, number 5. Write 225% as a decimal number. Remember, 225% can also be written as 225 over 100. A percentage is a fraction with a denominator of 100. All right? 225 over 100 could be written as 225 divided by 100. When we divide, our decimal point moves to the left. All right? So 2 places to the left based on the number of zeros. So 1, 2. So I see that my final answer would be 2.25. So 225% written as a decimal would be 2.25. Next, number 7. 4.5 minus 3 3/4. So here I've got my problem. 4.5 minus 3 3/4. I need to change my decimal into a fraction because that's what the book tells us to do. Okay, so I'm going to write my fraction as a fraction with the numerator of 5 and the denominator of 10. Why? Because the 5 is in the tenths place. If it would have been 4.05, my denominator would have been 100. That's right. Very good. All right, but in this case, it's in the tenths place, so my denominator is 10. So now I can show my fraction as my decimal, can be shown as a fraction as 4 5/10 minus 3 3/4. Okay, very important. When solving fractions, addition and subtraction problems, we need to make sure that the denominators of both of the fractions have the same, are the same, okay? So we need to find the least common multiple between 4 and 10. In this case, the least common multiple between 4 and 10 is 20. So in order to get that, I need to multiply 4 times 5. And whatever I do to the denominator, I need to do to the numerator as well. So 4 times 5 is 20, and 3 times 5 is 15. Next, in order for my 10 to turn into a 20, I need to multiply it by 2, because 10 times 2 is 20. So whatever I do to my denominator, I will also do to my numerator. 5 times 2 is 10. Now I've got 4 and 10 over 20 minus 15 over 20. Okay, I can't take away 15 from 10, so I've got to borrow from the 4, make that a 3. And now I need to add a whole number fraction to this fraction. And that's determined by the denominator. So 20 over 20 plus 10 over 20. Remember, when we add and subtract fractions that have the same denominator, that have like denominators, we only focus on the numerator. So 20 plus 10 is 30. Okay, so let's cross this out and put 30. So now I've got 30 over 20 minus 15, which gives me 15 over 20. Same thing. We've got the same denominator now, so we're only focusing on that. And now I can simplify. Well, which number goes in evenly into both 15 and 20? And let me fix that. I usually put that down. So 5 goes in evenly into both. 5 goes into 15 3 times evenly. And 5 goes into 20 4 times evenly. So our final answer for number 7 would be 3/4. Now I know I only give you the answers and we only work through the problems of the odd number, but you can use the same process in the even number answer. So if you're wondering how to do a problem, most of the times they're reflected in the odd number problems that we do here. And once again, I'll remind you, you need to show your work in all the problems that you do. You need to make sure that you're turning those in as well. And by the way, great job. I've been going through your stuff and a lot of you have been showing your work. So great job. Number 9, we've got 2 1/2 squared, okay? So the entire fraction or the entire mixed number is inside the parentheses and it is getting squared. So that means we are gonna take 2 1/2 times 2 1/2. When multiplying mixed numbers, we need to make sure that they're changed into improper fractions. So I'm gonna take 2 times 2, which is 4, plus 1, which is 5. So now I've got 5 over 2. This is my improper fraction. It's the same thing, so I'm going to do the same thing here. 2 times 2 is 4, plus 1 is 5, 5 over 2. Now I can multiply those two numbers together to give me 5 times 5 is 25, 2 times 2 is 4. And now I've got to change from going to a mixed number to an improper fraction. And from an improper fraction, my final answer must be converted back into a mixed number. All right, so how many times does 4 go into 25 evenly? It goes into it 6 times evenly to give us 24. And 25 minus 24 is 1. Okay, so we've got a remainder of 1. Just so you guys see what we did. We took All right, our denominator is our divisor, our numerator is our dividend, I'm sorry. 4 went into 25 6 times evenly. We subtracted it and got a remainder of 1, and we wrote our remainder as a fraction to give us 6 1/4. In case you were wondering how we got there, okay? Again, you can always pause the video, rewind it, and go over it again. And obviously, reach out to me if you have any questions. Next, number 11. Oh, it's really small here. Number 11, we have 20 of the 24 members voted yes. What fraction of the members voted no? What fraction of the members? Oh, I read that wrong, I'm sorry. 20 of the 24 members voted yes. What fraction of the members voted yes? Not no. Okay, so we've got 20 voted yes and 24 people voted. That's 24, 12. So 24, there's 12 in a dozen. 2 times 12 is 24. So that's how we got our denominator. So we've got 20 over 24. Instead of putting a division sign, let's see what number goes in evenly to, which number goes evenly into both of these numbers. Okay, so let's try 4. Okay, 4 goes into 20 5 times evenly, and 4 goes into 24 6 times evenly. So our fraction that represents this ratio is 5 6. Okay, so your final answer should be 5 6. Our next question is right below here. We've got 9 1/3 times, let me check here. Where am I? Number 13? Oh yes, apologies. W plus 3/4 equals 9 1/3. We have a missing factor. We have a missing term. In order to find the missing term of an addition problem, we must take the known term and subtract it from the sum. So the sum of this particular addition problem is 9 1/3. To find the missing term, I need to subtract the sum by the known term, which is 4 3/4. We're dealing with fractions again. That means we need to change our fractions need to have a common denominator, okay? In order to find the common denominator, first we need to find the least common multiple between 3 and 4, so the denominator. I have found that the least common multiple between 3 and 4 is 12. Now, how do we find least common multiples, you ask? Let's go over here. All right, 3 and 4. Multiples are basically multiplication problems. Okay, so the first multiple of 3 is 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3, 6, 9, 12, and 15 are all multiples of 3. Next, my multiples of 4, are 4 times 1 is 4. 2 times 4 is 8. 3 times 4 is 12. And 4 times 4 is 16. And 5 times 4 is 20. Okay, so 4, 8, 12, 16, and 20 are the first 5 multiples of 4. The least common multiple, okay, so the least common multiple that these two numbers have in common is 12, okay? Just in case you forgot how to do that. Now, in order to make 4 a 12, I need to multiply it by 3. So 4 times 3 is 12. Whatever I do to my denominator, I must do to my numerator, so 3 times 3 is 9. Same is true for 1/3. To change 3 into a 12, I need to multiply it by 4. So 3 times 4 is 12, and 1 times 4 is 4. So now I've got my problem set up. I've got 9 4/12 minus 4 9/12, okay? Run into a problem here though. I can't take away 9 from the 4, so I need to borrow from the 9, making this an 8, and I'm gonna borrow a whole number fraction from the 8, and that's gonna be represented as 12 over 12, based on our denominator. So now I can take 4 plus 12, which is 16, okay, so let's cross this out. So now I've got 16/12. So 16 minus 9 is 7, and 8 minus 4 is 4, to give us the final answer of 4 7/12. All right, there's no number that goes in evenly into both 7 and 12. 7 is a prime number, so the only number we could work with would be 1 and 7 doesn't go into 12 evenly. So let's go on to our last problem. We've got 6.75 plus 12 plus 4.6. Now on your problem, they're all written out horizontally, but when you solve these, it is important that you, it is important that you line them up and that your decimals are lined up and that your place values are lined up. So the 6, the 2, and the 4 are all in the ones place. The 2 is, the 1 is in the tens place. The 7 and the 6 are in the tenths place, and the 5 is in the hundredths place. Now, to avoid confusion, we are gonna add zeros to the missing place values, okay? So I've got a 0 in the hundredth place, a 0 in the tenth and hundredth place here, because no number is given to us. And then I can go ahead and add. So 5 plus 0 is 5, 7 plus 6 is 13, and I carry the 1. 6 plus 1 is 7, plus 2 is 9, plus 4 is 13. So I've got to put my 3, raise the 1, and carry the 1. So 1 plus 2 is 2, to give us this final answer of 23.35. That's it for today. Just problems 1 through 15. I hope you watched the entire lesson. I know it was a little long. I'm sorry, but at least you didn't have to do all 30 problems today. All right, guys. I'll see you tomorrow. Take care. Bye.